In this lecture, I will describe about symmetrical bending and unsymmetrical bending. First, you remember what is the meaning of pure bending. Bending is a very severe form of stressing a structure. So, simply you just remember what is the meaning of pure bending. Now, pure bending is a condition of stress where a bending moment is applied to a beam without the simultaneous presence of axial, shear or torsional forces. Pure bending occurs only under a constant bending since the shear force is equals to 0. Means pure bending takes place when there will be no shear forces acting on the beam. And also bending moments are along the axis of the member. So this one is your pure bending. There will be no shear force acting. Then what is the difference between symmetrical bending and unsymmetrical bending? So first you remember the symmetrical bending. So symmetrical bending means in which case we can say this one is a symmetrical type of bending or uniplanar bending. You can say symmetrical bending or uniplanar bending. So if plane of loading and plane of bending and plane containing principal centroidal axis of inertia of the cross section will coincide to each other, then you can say this type of bending is known as symmetrical bending. Means you can say plane of loading. You assume this one is your plane of loading. This one is your plane of bending. And another is your plane containing principal centroidal axis. If coincide at a single point, then this is known as uniplanar bending. Example, circular cross section, square cross section, rectangular cross section, equal arm I section are the symmetrical bending. Then on symmetrical bending, if plane of loading does not coincide with plane of bending or plane containing principal centroidal axis of inertia, then you can say this is known as unsymmetrical bending or non-uniplanar bending. For example, L section, unequal I section, T section is a unsymmetrical bending. So next see the assumptions for. So assumption you must take when you consider symmetrical or unsymmetrical bending. So first assumption is the plane sections of the beam remain plane after bending. Means before loading the plane section is like that after bending. So this one is your first assumption. Second assumption is the material of the beam is homogeneous and linearly elastic. So material is homogeneous. Homogeneous means what? A material of uniform composition throughout that cannot be mechanically separated into different materials. Means the composition should be uniform throughout the material and you cannot separate the material by mechanically. Then linear elastic means all the operation done within the elastic limit. And third assumption is there is no net internal axial force. Next one is your mathematical calculation. So mathematical calculation for symmetrical and non-symmetrical bending, you just remember how you can calculate direction of the neutral axis. This one is your expression tan alpha is equals to IU divided by AV into tan phi, where alpha is your angle between, this one is your alpha is your angle between the principal axis of inertia and the neutral axis and is measured clockwise. Phi is your angle between the plane of load and the vertical longitudinal plane. IU and IV are the moment of inertia about UU and VV axis. Then next, how you can calculate the bending stress? So this one is your expression for calculation of bending stress. So sigma is equals to mu divided by IU into V plus mv divided by V into U. U and V are the perpendicular distance of a point from the principal axis. Next one is your sign convention. So sign convention for this mu and MV are the movement for UU axis and VV axis. So mu is considered positive if it produces tensile stress, and MV is considered positive if it produces tensile, otherwise it will negative. Means mu consider positive it produces tensile stress, or it will consider negative it produces tensile stress. So next, see a problem related to the above chapter. So see the problem. A rectangular beam as shown in figure. This one is a rectangular beam. Is 15 centimeter wide and 20 centimeter deep. This one is a 15 centimeter wide and 20 centimeter deep. It is used as a simple supported beam. So this one is a simple supported beam on a span of 6 meter span of the simple supported beam. This one is your 6 meter. Two loads 5 kilonewton each. This one is your two load 5 kilonewton each are applied to the beam, each load being 2 meter from a support. So this one is your distance 2 meter. Means two loads are acting from the support at a distance 2 meter. The plane of load make an angle of 30 degrees. So this one is your plane of load making an angle 30 degree with the vertical plane of symmetry. Find the direction of the neutral axis and bending stress at a point A point. This one is your A point. You have to calculate this one. So see, so this one is your rectangular cross section having dimension 15 centimeter and 20 centimeter. So first you have to calculate IU and IV. IV are the moment of inertia about x axis and y axis, or UU axis, VV axis. So you have the formula BDQ by 12, DBQ by 12. So put the value of B and D, then get IU and IV. One IU value is 10,000 centimeter to the power fourth. IV is 5,625 centimeter 4. Then how you can calculate direction of the neutral axis? So you have a expression for direction of the neutral axis. So this one is an expression. Tan alpha is equals to IU divided by IV into tan phi. So put the value IU, this one is your IU, IV, this one is your IV, and tan phi is your 30 degrees. So this one is your phi angle. This angle is known as phi angle. So phi angle is 30 degree. So tan phi is equals to 1 by root 3. Finally, alpha is equals to 45.75 degree. This one is your direction of the neutral axis. So how you can mention in figure? This one is your direction of the neutral axis. So this one is your major principal axis, this one is your minor principal axis, then this one is your neutral axis. So neutral axis is situated in between the major principal axis and how much the angle, that is the neutral axis angle, that is alpha. Alpha is equals to 45.75 degree, which is clockwise direction. Next, bending stress at point. So this one is your point A. You have to calculate bending stress at point A. So you put the formula. This one is your sigma is equals to mu divided by IU into VA plus MV divided by E into UA. So you have value IU and IV. Then you have to calculate UA and VA. So UA and VA, UA V at the coordinate of the at point A. So at A point, the coordinate of this one is how much? So this distance is known as UA, this distance is known as VA. This one is your VA and this one is your UA. So UA becomes how much? 7.5 centimeter. VA becomes 10 centimeter. You say UA is 7.5 centimeter, VA 10 centimeter. These are the coordinate at point A. So both are positive because A is situated at the first quadrant. So X and Y or U and V are the positive coordinate. Then sign convention for MU and MV. So MU and MV both produces compressive stress at point A where UA and VA are both positive. Therefore MU and MV are both negative. Why MU and MV are negative in nature? So see, this one is your which type of cross section? This one is your sorry, which type of beam? Na simple supported. So whenever loads are acting, then it becomes deflected. Then the upper side becomes compressive in nature, lower side become tensile in nature. So upper side means the point A is situated, means the upper side become compressive, lower side become tensile in nature. If the point in you can take a point here B. So B is positive in nature. If you take one beam, that is the simple cantilever beam in place of simple supported beam, then the condition will be like this: the upper side become tensile, lower side become compressive. So at that time A becomes positive. So here mu and me negative. Then mu value and mv value. So mu is m cos theta, mv is m sin theta. Minus sign means that is produces compressive. So m is movement force into distance. So force is your C force is 5 kilonewton, distance is 2 meters. So 5 into 2 is known as movement. So put the value. So this one is your mu value, this one is your m value. So next, how you can calculate bending stress at point? So this one is your expression. You put all value, then get sigma A is equals to minus 1532.7 Newton per centimeter square. This one is all about the symmetrical and unsymmetrical bending. Thank you.